second video on interview questions for FEA stress analysis with answers. So my last video was about some interview questions asked about stress analysis, and I'd also discussed their answers. In this video, I will be discussing with you some more interview questions for FEA stress analysis along with their answers. This is going to be slightly more uh, advanced than what was there in the previous video, so do keep uh, do look out for this video. And if you like this video and want to view similar content, do like and subscribe to my YouTube channel. Thanks. What is structural nonlinearity? So structural nonlinearity is a phenomenon where the slope of the load displacement curve does not remain constant, or in other words, the stiffness of the system does not remain constant. So if you look at this image on the screen, you will see that the load versus displacement plot is a straight line and there is a cross over it. So in a nonlinear analysis, in a nonlinear system, it will not be like this. It will not be a straight line. So that is what is called structural nonlinearity. If you look at the expression for the stiffness matrix K, it is integral B transpose into D into B into dV. So B matrix is the strain displacement matrix, D matrix is the constitutive matrix or the stress strain matrix. So when these matrices are not constant and vary along with the deformation, we have the K matrix will also not remain constant, and the stiffness of the system will change with time. So that is what is called structural nonlinearity. Now you can see there are two matrices that contribute to this, that is the B matrix and the D matrix. We'll be speaking more about this in the upcoming slides. So what are the different types of structural nonlinearities? There are three main. One is geometric nonlinearity, the second one is material nonlinearity, and the third one is contact nonlinearity. So these are actually causes of structural nonlinearity, but generally we refer to them as different types of structural nonlinearities. So what is this geometric nonlinearity? So geometric nonlinearity is a phenomenon when the stress strain matrix P does not remain constant. So we can see that from the expression we have seen already, the stiffness matrix is basically a function of the B matrix and the D matrix. When the B matrix is not constant, then the stiffness matrix becomes nonlinear, and it is due, and this type of nonlinearity is called geometric nonlinearity. So practically speaking, what it means is when the deformed shape is very much it becomes significantly different from the undeformed shape, we have a nonlinearity called the geometric nonlinearity. This is, for example, buckling and things like that. So what is this material nonlinearity? So material nonlinearity is when stress is not proportional to strain. This can be due to yielding, this can be due to hyperelasticity, change in temperature, etc. So basically anything that changes the material properties during the course of deformation will cause material nonlinearity. So for example, if you take the stress strain diagram of steel, beyond the yield point the stress strain plot will not be linear. So that is a structural nonlinearity. So what effect does it have? So the stress strain plot will not be a straight line. Because of that, the load deformation plot will also not be straight line. So now, mathematically speaking, according to the FEM theory, we already know that the stiffness matrix is a function of B and D matrices. When the D matrix is not constant during the course of the deformation, it is called material nonlinearity. So the last type of nonlinearity that we are going to see is the contact nonlinearity. So what is this contact nonlinearity? When the contact status during the course of deformation changes, it is called contact nonlinearity. For example, something which is initially not in contact comes into contact later, or something which was initially in contact goes out of contact. So all those things are a part of contact nonlinearity. So the location where the contact was there, if that changes, that is also contact nonlinearity. So these are the sort of things that we have to deal with in the nonlinear systems. So in order to explain to you mathematically, if you see during the solution process of a linear system, we solve the equation F is equal to K times delta. So now what happens is that uh, here initially you will have the full stiffness matrix, but in the second stage what we do is that we eliminate all the redundant degrees of freedom. So wherever we have given fixed boundary condition, wherever we have restricted the degrees of freedom, all those locations we remove those terms, those rows and columns, right? So as you would have seen in the textbook. Now what happens is that because of this contact nonlinearity, so those degrees of freedom that we are going to exclude, they get changed. So because of that, there will be a nonlinearity in the system. Thanks you friends. The stiffness of a system is dependent on its boundary conditions. When the boundary conditions change, the stiffness will change. And this change of stiffness due to change in boundary conditions is called contact nonlinearity. And if you like this video and want to view similar content, do like and subscribe to my channel. It is your encouragement and good response that encourages me to more such content where you can where I'll tell you the answers to the interview questions, and it will help you crack the interviews. Many of my friends refer to my content for cracking the interviews. Before the interviews, they check all the questions that I post and those things. So I encourage you to have a look at this video, and do remember to like and subscribe.